Hi, and welcome to this talk on quality assurance in safety critical software system development. In this talk I'll go through the motivation for why we wrote the paper at all, what we're trying to do and what we're trying to consider. We'll have a look at the whole idea that safety critical systems, and indeed almost every system, are becoming increasingly large and complex, and this is leading to challenging us on our ability to assure the quality of it all. Now we'll have a look at the characteristics of complex systems and why our existing quality assurance methods aren't quite adequate to deal with the challenges that they pose. We'll have a look at software development itself, and I'll argue that software development involves some elements of complex processes and some elements of complicated processes, sometimes mixed in together. So with that, we can then have a look at quality management in an agile environment. We're using agile methods. All right, so we have all the tools, and we'll have a look at quality management in agile methods. Because I don't think that the existing quality methods are adequate, we'll have a look at what is done in other circumstances to assure quality in places where process compliance is just not possible. So, and yet, we do get some pretty good outcomes. So the question is, how do they do it? Then we'll have a look at, assuming we apply that to software development, would that be sufficient? And personally, I don't believe it is, because we have this confirmation bias, and I'll discuss what that is. Before we have some sort of a discussion about, well, where does that leave us, and draw some conclusions about it. So let's look at the motivation for this paper. Now, the motivation really is that our software systems are getting bigger and more complex, and this is also true in some of the safety critical domains, particularly and specifically medical device software development. Now, in that environment, as with all our software development environments, agile software development methods are quite popular and are being taken up. Whether they are being adopted well or not is open to question, but there is no doubt that there are enough advantages in agile software development methods, and it is attractive enough that inevitably that will be the method that's used. And so we'll have to have a look at that. Now, existing quality assurance methods are largely process-based and depend on compliance with process. The whole idea is from the total quality management movement, largely from Deming and arising out of that the quality of the end product is a reflection of the quality of the process that went into them. So there's a great deal of reliance on assuring the quality of the process on the assumption that that will actually lead to appropriate quality in the products, and this I don't think is necessarily true. Now, in the absence of repeated and predictable processes, how can we assure quality, particularly with an agile team that develops software for safety critical systems? So this is the environment in which we're just thinking about, well, what do we do? How could we do it? So to examine this, we'll have a look at the various parts of it. We'll start with setting the scene with medical device software systems. The safety critical medical device software systems are getting bigger and more complex. Pretty much, I think it's more a case of, well, because we can, we start to do them. Now, software is now an essential component in medical device control functions. There's no getting around it. No? Software is permeating everything, and software is just as much a part of a medical device as it is anything else. And medical devices could be entirely software. There is at least one application which I believe is a dispensary type application that is classified as a medical device, but it's entirely software. There are also things that are in fact devices, such as the bionic ear. There's also work going on for a bionic eye. There are the heart pacemakers that have got quite a bit of software in them as well. And there are also devices like wheelchairs that work from brain activity. We're also working on prosthetics that are got quite a bit of software that drives them. So there's quite a lot of devices either existing, close to being used, or envisaged that are both complex and dependent on software. The newer, more complex systems require new solutions, and it usually involves innovation. I mean, if you're going to do something new, it's going to be innovative. All right. So look at complex systems. Now, software is the main source of innovation in many systems. It's also the main source of complexity. Now, these things bring benefits, but they also bring unpredictability that arises in complex systems. Because in a complex system, you're dealing not only with the parts and the characteristics of the parts, but the interaction between the parts. And it's the interactions that tend to be a little bit unpredictable. Since there is a potential for harm in medical devices at least, there has to be some kind of an oversight and some sort of an approval scheme to assure that these devices are safe. Now, obviously, that can be difficult to do when you're dealing with a complex device. Now, it is difficult to discover all of the errors before release. Now, evidence of that is that in 2011, 25% of all the recalls of software devices, medical devices, were due to software errors, and only software errors. So we haven't got it right. Innovation itself is necessary but risky. But if you really wanted to get things perfect, you just stop all the innovation and you just refine and refine and refine the existing thing you're doing until you got it perfect. But that has never happened. It's unlikely to happen. We will have innovation. And the obvious question is, well, software development gets trashed for its reputation for failure, but is it any worse than any other innovation? And it appears to be not. When you look at innovation in new product development, and there have been a couple of studies spaced over a number of years, the consistent finding is that about 40% of new product developments end in failure. And we're not talking about spectacular failure or damaging failure or anything like that. Just simply failure. That is, they did not achieve what they were intended to achieve. They didn't achieve their commercial success, or they weren't perceived by the market the way they're supposed to be. They didn't sell much, or simply they failed at 40%. So software development is not significantly different from any other form of innovation. It doesn't excuse it, but let's just get it in context. Software development has characteristics of design, or involves some elements of design and involves some elements of production. So let me explain that. Design is complex. It's a complex activity. It is really difficult to predict the outcome of design. It tends to just happen. The outcome, though, is retrospectively coherent. Once you have the design, you can look at the design and examine it in terms of what it was required to do and say, yes, it will do it. But it's difficult to go from the requirements to the end design. It's backward, as I say, retrospectively coherent, not forward predictable. The way that designers tend to work is they tend to propose solutions, come up with solutions, and continue to do that until they find one that works. Right? So they propose a solution, examine it against its constraints and its objectives, and determine whether it fits within the constraints and the objectives. And if so, they accept it. If not, they don't. It also happens that one of the observations was that brilliant design comes from somebody examining the constraints and figuring out whether they are actually constraints or not. And if they are, trying to relax one or the other. And there have been some very famous cases of that. That you manage the process, the innovation, the complex process by observing and responding to emerging trends. Production, on the other hand, if you're producing something, you're going from something to a known something else, and it's a complicated process. That is, it may be difficult, but it's entirely predictable. It is possible to routinize in a process. So something might be complicated, you may have difficulty figuring it out, but having figured it out, you can actually put it together in some sort of a process that will make the whole thing repeatable. All right? The way of managing these is you then analyze, sense, and respond. So you analyze the data, you sense, you make sense of the data, and you respond to that data. And you can do this because the future is predictable based on the past. What information you have now is applicable to the future. Right? So you respond to expected trends. Software development itself involves both design and production. Now by design, I'm including all of those activities that are to do with problem solving, determining what design constructs what constructs to use, putting them all together to achieve the functionality or the characteristics that you require. That is, I guess you call it the fuzzy front end of software development. Now, there have been methods that have incorporated some element of design, and these have got a fine history. We go back, I think, into the mid or late 70s with the spiral process that was proposed by Barry Bing. That was one of the first ones that acknowledged there was going to be some experimenting before you settled on what actually was the final product. I think his was risk-based, but nevertheless it was one of the first of these agile methods. That was followed by joint application development and rapid application development that was favored when people basically they wanted to try proof of concept and try something out and find out what would work before committing huge amounts of money and lots of people to it. There's been various forms of incremental development. Tom Gilb has been advocating incremental development for many, many years, or evolutionary development. And that most recently, the Agile methods have incorporated design as part of what they were doing. There's been a gradual shift to collaborative problem solving as opposed to simply something that resembles a production line. Software production happens when you're converting the design into executable software. Now that is actually a production process. There are predictable ways of doing it, and there are ways of ensuring that it's done well or done right. Your verification, your validation all comes in, and you can get errors of production. And but we're getting less and less of them because we're actually getting much better at it with better tools and better predictions. Nevertheless, you can get errors of production, but we have these processes of production or activities of production in software development. So we have this whole idea that software development or software design and development involves some elements of design and some elements of production. The more innovative that you're being, you'll have more design, and the less innovative will have less design. Design methods versus production methods. If you're trying to design something, you're trying to solve something for the first time, you tend to have processes that have less concentration on quality assurance because you really want to find out whether something works first before you impose all the quality controls on Now, with software development, it can be several months between the original concept, inspiration, if you wish, and seeing the realization of that concept, so you can determine whether that in fact would work or not. So it could be a number of months. Now, in that number of months, essentially, you have to suspend disbelief. You have to accept that the result may not be such good quality, and that you may have to retrofit quality, or you may have to, once you've got your design, start again and produce something that's high quality. Nevertheless, in design with software or design with anything, you have to loosen off the quality controls in order to get the design realized. Once you have the design, then you're into matters of production. And the whole idea with production is you tighten up the quality management so that you detect all of the errors as early as possible, so that they don't manifest themselves and they don't bury themselves in the product on the way through. But you have this contradiction, all right? For design, you loosen off the controls. For production, you tighten up the controls. Now, that's really hard to do in one software development project. So, particularly as with in Agile software development, the design and production is not distinct and separated. In any one sprint, you'll get an element of design and an element of production all at pretty much at the same time. Now, that leads to the whole idea that in Agile software development, how do they assure their quality? Because although there's not a formal quality management function, and there certainly hasn't been published a great deal of information on how you assure quality in Agile software development, clearly they're getting enough of it right to be commercially acceptable. So how does this happen? Well, Agile software development relies on self-managed teams, and these self-managed teams do rely on having capable people. That's capable enough. And capable people, they know how to manage the design. They know when it's going right, they know when it's going wrong. They're very experienced people, and they've seen a lot of these things before, and they can sort of apply appropriate amounts of quality management at the time. They know when to loosen it off and when to tighten it up. So they can self-manage the design, and they can self-manage the quality. Now, less capable people are better supported by process. Okay? Now, there we get a problem. If you don't have enough experienced people and good quality people on your Agile team, you will have to support them with process. If you put in too much process, you will strangle the innovation. I've forgotten the exact term for it, but strangle will do it. So how can we assure quality when we're relying on self-managed teams of people who may or may not be very experienced? Let's have a look at how some other fields do this, some other endeavors, because not everybody has got a process or can sit down and take the time to do it. Now, think in terms of a surgical team, or a firefighting team, or flight deck operations on an aircraft carrier. The one I didn't want to put in there was combat teams. In all cases, you want as high quality outcome as you can get. You don't want anybody to die, and yet the situation is likely to be quite fluid. The team is going to have to react to changing circumstances, and there will be a whole lot of emergent phenomena coming through. So how do these people do it? Well, there's been a couple of studies. One into combat decisions was modeled based on firefighters. The study was done by Gary Klein and his team, and he's written a few books about that. It turned out they came out with the theory of naturalistic decision making. The other study that I quite like was a study of flight deck operations conducted by Carl Weick and his team, He's published quite an interesting paper on it in 1993. It had a fabulous introductory paragraph that put it quite well. Anyway, without diverting into stories, these teams, they found, particularly when Carl White looked at the high reliability teams, like surgical teams and flight tech operations, they had some characteristics. They were preoccupied with failure. They were all very concerned with failure. Never mind did it look good. I mean, if it failed, it's no good. So everybody got preoccupied with, could this thing fail? And if so, how do we prevent it failing? They had a reluctance to simplify things. So they didn't just wish away abnormal events. Any event was looked at in terms of what did this mean? How did that affect things? There was a sensitivity to operations. The operations overrode everything else. And it really was a case of, will this work? Not is this desirable, but will this work? There was a commitment to resilience. And by resilience, they looked at what is likely to happen if we had an unusual circumstance. Could we handle it? What do we do in these circumstances? What do we do in those circumstances? What if? This ability to cope with a whole number of eventualities is something that these high reliability teams considered quite a lot. And there was a difference to expertise. You might think that's sort of obvious, but it isn't always happening. So here we have precedents from or models from in other domains where a agile software development team could follow. So let's have a look at agile software development as a high reliability or high performance activity. So we'll go through the characteristics. A preoccupation with failure. In agile software development, there's the increasing use of the definition of done. And in that definition of done gets placed all of those things that people know ought to be completed before the software is fit for release. Now that's a mechanism in which all the lessons learned about that which could compromise safety can be placed. I don't think it's a complete answer, but it is a good answer. The reluctance to simplify. Now, in agile software development, that would seem to come through incorporation or close working between the development team and the customer and the end user, if the customer and the end user are different. Similarly, sensitivity to operations is something that would seem to come through frequent close involvement of the customer and the user. No, I certainly can't say that this happens in all circumstances and all projects with all agile teams, but I am arguing that agile software development has these concepts within them that allow it to act like a high reliability organization. The commitment to resilience. Again, agile software development methods usually have the concept of retrospective, and the intention is to learn from your failures and get better, and to preserve them in some fashion, to alter the way of working so that we do avoid these problems. And I think that serves the intent of a commitment to resilience. Deference to expertise. It's a little bit unclear. Agile software development methods certainly have frequently indistinguished teams, that is multi-skilled teams, and tend to not bring in specialists. Doesn't mean they can, it doesn't mean they shouldn't defer to expertise, but I would put that as one of the weaker points of agile software development, as it seems to be popularly advocated. Now, if they do all that, assuming an agile team conforms to all those practices and implements them quite well, would that give them adequate assurance of safety? And I don't think it would. And the answer is this very human characteristic of confirmation bias. A confirmation bias is a tendency to seek and interpret evidence in ways that support what, the existing beliefs, the expectations, or an hypothesis. Now, software developers develop a system they believe is going to work. Now, they're not going to sit around then and say, well, it won't work. I mean, they designed it to work. They will believe it will work. It will take a great deal of evidence to tell them that it won't work. So they're unlikely to contradict their own hypothesis. And usually the way that this has got around in software development is to have an independent team of testing or an independent team of review, independent of the people who developed it. Agile software development doesn't have that. Doesn't mean it can't have that, but Agile software development at the moment, as is advocated, doesn't have it. Developers do tend to prove the system works as intended. Agile safety critical development methods do need independent evaluation both of design and production. So they will have to break away from the currently advocated Agile software development methods to put this in. Now, in medical devices, quality management for medical device software, let's have a look at, all right, if it's going to be developed by an Agile software development team, what are we going to do? Currently, it's dominated by regulations. The regulations are modeled on ISO 15288. That is, when medical devices started incorporating software and somebody thought about it a bit, they said, well, the best we can do at the moment is we will put in quite a lot of validation. And that validation was modeled on the 15288 validation process. And so quite a lot of medical device software systems have to comply with the requirements of validation. The underlying assumption is that the integrated whole will be the sum of its parts. In ISO 15288, essentially it says if you assure all the processes and you develop all the components correctly, then the integrated whole will function correctly. Now that's not true. The complexity arising from interactions among the components may, not will, but may yield unexpected results. That is a feature of complexity. And the reason why I say may is because I can't say that all medical device software systems will be complex or will produce these unexpected interactions, because there are differing levels and different degrees of complexity. And obviously, the more complex it is, the more likely this is to happen. But less complex systems don't necessarily produce unexpected outcomes in that volume. So it really, the medical device industry really ought to consider how they could assure the characteristics of high reliability organizations in their software development and how we can do that. Compliance to the validation requirements may contribute to safety, but it won't guarantee it. So what does all this mean? Well, we know that Agile software development combines design and production. Designs, we think, should be evaluated against guidelines. You can't assure a design by demanding conformance to a process. It just doesn't work that way. With the design, you produce it and then you evaluate it against guidelines and constraints and objectives. Designs are then transformed into a product using production processes. Now, safety in complex systems depends on the integrity of the components and the interactions between the components. So the components may be correct and function correctly, but flaws could arise from, design flaws could produce failures. And we know that's generally true. So concluding from all of that, Medical software systems design and development will adopt agile software development methods. And those methods are too attractive to ignore. They will do that both because it's economically attractive, socially attractive, and it's a way of addressing complex software development problems and situations. Many agile software development practices do mirror or conform to the practices of high reliability organizations. So whether unconsciously or by accident or not doesn't matter, but some of the practices of high reliability organizations are observable in agile software development methods. Agile software development teams do not always perform or support the high reliability activities. Yeah. So it means there's a way to go. Formal claims that a software system is safe normally require some external proof of that safety. So far, the methods to review software systems remain informal. Software system design, they do remain informal and relying on professional skill rather than any formal validation. I think this is the nature of design. It's always going to rely on formal skill. Design faults are usually more subtle and of more consequence. So we, in the software development industry, we really ought to consider methods of evaluating designs so that we can try to determine how safety is affected by design and how we can evaluate for safety of the design.